Hello and welcome to this webinar about Modbus with PLCnext. My name is Stefan Brinkmann and I work for the IMA automation training team. So let's have a look what we are going to do today. So I'm going to explain the basics of Modbus, start with Modbus RTU and Modbus TCP. And then I will show you the latest feature of PLCnext, which is the built-in Modbus TCP client. So what is Modbus? The first version of Modbus is called Modbus RTU, which stands for the data is transmitted in a binary form, which is the Modbus RTU, what we call it. And then there has been a change or an update, second version, which is called Modbus ASCII, where sort of a binary form, the protocol is using ASCII characters so that it is human readable. But the Modbus protocol does not provide any security against unauthorized commands or interception of data. We will see it's not encrypted in any form. It's based on a master-slave architecture. So we have a master, which is usually the PLC, and then we have a slave. In this case, it's an energy meter, or it could be any other thing. So just for the terminology. And one master can connect up to 32 slaves, as we will see in total. The Modbus telegram or protocol is very simple. So we have a slave address. So each slave has an individual address. Then we have a function code which determines what kind of operation we are going to do. If you want to read something or want to write something, I will explain that in a second. Then we have the data that we want to transmit and the checksum. It's pretty much straightforward. So maximum size of this frame is 256 bytes. And between each telegram, there must be a pause of 3.5 characters. So you can see that there's a pause, a telegram, and so on. So how long is a pause of 3.5 characters? So that depends on the transmission speed. So let's assume a baud rate of 19.2 kilobit per second. Then we can make a calculation so that the pause is around about 2 milliseconds. And every byte is sent in an 11-bit frame. So we have the 8 bits for the byte. Then we have a start bit, a parity bit, and a stop bit. And with a parity bit, we can determine if the bits have been transmitted correctly or if there has a bit has changed. So this is the most reliable one, which is very common in the industry, is called RS485. So it uses is 150 kilobaud. The maximum length of a cable is around about 1,200 meters. And as I already said, one master can connect to up to 32 slaves. It's very important so that you have a resistor at the beginning and at the end of 120 ohm to prevent reflection on the cable. Especially when you have a very long cable, you need these resistors. RS485 uses 2 voltages, and with a difference of the polarity of the voltages, you have either a binary 0 or a binary 1, as you can see here. So the hardware that I'm going to use on my demo is an Axiline F RS Uni module. The controller is an Axiline C IXC F2152, which I'm using. The RS Uni, as you can see here, is a universal serial communication interface. So it supports different protocols, as we will see. And you can also see here that the resistor, this what I was talking about, the 120 ohm, is connected here or is built into the device at port 30 and 31. for the termination. Yeah, and the RSUni supports RS-232, RS-422, and RS-485. Of course, you can also use smart elements, but then you have a separate module for each of these protocols. Transmission speed can be configured up to 250 kilobaud. Parameterization via the PDI channel can be done, and of course, like all axial line devices, there's a device rating plate stored on the device. So for the configuration of the device, you can have different protocols. You can have transparent mode, end-to-end, X-on, X-off, and Modbus RTU. So with the function blocks that I will show you later in the demo, it is recommended to use transparent mode. Transparent mode means that the data that is coming via the serial interface is sent directly as process data, and the function block handles the Modbus protocol. Whereas when you select Modbus RTU here, then the Modbus protocol is handled by the hardware itself. But recommendation in combination with our function block, it is to use transparent mode, but you can also configure to use Modbus RTU. So let's have a look at the data model, which is also very simple. In Modbus, we have 4 different data types, 2 bit-based data types, 2 word-based data types. So we have discrete inputs, which is a bit, read-only, like a digital input. We have coils, also bit-based, but read and write like digital outputs. Then we have the so-called input registers, 16-bit word, read-only, like analog inputs. And finally, the holding registers, the 16-bit word, read and write, like analog outputs. And this model applies both to RTU and TCP, so use the same model. And then we have the function code. So this is an overview of the most commonly used function code. There are some additional function codes for diagnostic purposes, but you see we have also here bit access function codes and word access function codes. So we can read coils and inputs and write coils and so on. And there's also one command that can read and write several registers with just one command. When you set up a communication, of course, master and slaves must have a common function code, meaning that not all devices support all these function codes. So you have to look in the manual of the device that you're going to use and check which function codes are supported. There are 2 ways to store the data in the memory of the devices. The first one is, as you can see here, separated memory area for each data type. So each data type has a separated memory area that can be accessed by a designated address here, as you can see. So for each data type, we have a specific address area. And the data access is done via the start address and an offset. On the other hand, it's also possible to have a combined memory. So all of these data have the same start address plus a data type offset. So the same data can be read either bitwise or as a register, but you have to be careful not to use the wrong offset, because this will result in wrong data. So both models are supported and can be used. So in order to use Modbus RTU on PLCnext, you have to use libraries, and the libraries, the Modbus RTU library and also the TCP library, they are available in the PLCnext store. So just go to plcnextstore.com, and there you'll find the libraries for free to download. So with the Modbus RTU library, the main function block is the master function block here. And as you can see here, it's called the RSUni master function block. So this function block exists for all the different axial line modules and inline modules that you can use. So because this is hardware specific, this is need to check out. So if you're using the RSUni module like I do, you have to use the master for the RSUni. The function block can be activated, and with the mode you can select either, if it's set to false, then the RSUni needs to be set or configured as transparent. If you set this mode to true, then the Modbus Modbus data. This is just the interface to the other function blocks that will follow. And then we have two arrays here, one for input data and one for output data. And this is the process data that is connected to the RSUni module. And when the function block is connected, then the active output becomes true. And when there's communication going on, we see the requests and the responses, which should increase in normal operation. If there's something wrong, we have an error output here and a diagnostic output. You also have a slave function block. So if you want to use the PLC as a slave, you can activate it, specify an address and a baud rate, and then you see the different data types here and also the process data for the RSUni. And then for each function code, there is a separate function block. So in this case, it's the function code 3 function block, meaning reading hold-in registers. You can activate the function block, and now you have the option to send a request. So you can manually trigger the reading process, or you can enable the poll mode, and then you can specify an update time, so it's cyclically reading the data, like in this case. Then you have to specify the address of the slave, which you want to read the data from, specify the first register address, and then how many registers you want to read. And then the data, if successful, is stored into this read data array. You can see here if we have active and busy, if the communication is going on. When the data has been read, there's a rising edge on the done exit output here, and we have diagnostic information available here on these 4 outputs. So let's have a look. So what I have here is my Axula NF2152 with an RSUni module, which is connected to an old EM Pro energy meter, which supports Modbus RTU. So I have prepared this demo here. There you can see it. So let's jump right into it. You see it's already connected, it's online. So here is my RSUni master function block, which is set to true. And you see it's reading, so the requests and the responses are increasing. And when this function block is active, I activate my function code 3 function block, which in this case is reading the operating hours of the EM Pro. So you see poll mode is activated, device is at 2 seconds, poll interval. You see the start address, which you can get from the manual of the EM Pro. So each device has that supports Modbus must have a Modbus table where all the registers are specified. And the data is stored in 2 registers, so register 50,512 and 50,513. This is where the data is stored. But then the data is stored in a word array in this case, as you can see. So you have raw data. And in order to get really the real value, you have to decode the data. So in this case here, just on the top here, you see you have 2. This is standard for Modbus. So first the high word, then the low word. And then I have written a small function that combines these 2 words into a real value. Now we can have a look inside here. So it's not very complicated. So I take the high word and the low word, and by shifting the high word 16 bits to the left and doing an OR manipulation, I can create a double word of these 2, and then I convert this into a real value. There's a specific thing here on the operating hours. So in the manual, it's said that the operating hours have 2 decimal digits. As the decimal number cannot be transmitted in a word before the EM Pro sends the data into via Modbus, it multiplies the value by 100. And this is why I have, when I receive the data, I have to divide the value by 100 to get the 2 decimal digits. And then you can see here I have my operating hours. Now, if you have a second register that is in a different area, you can simply add a second instance of the function code 3 function block, which I did here. Configuration is the same. The only difference is here now the start address. It's only one register, and this is the temperature of the built-in temperature sensor. Of course, you need a different read data area, and then you can, it works the same way, do the decoding here, and then you get the temperature inside of the module. So this very simple way of using the Modbus RTU library. So let's now have a look at Modbus TCP. Actually, it's the same protocol, but just a different technology. So this is the Modbus TCP frame. So let's start at with the yellow part. So we have a function code and the data, like on the RTU, the same function codes here. But then here the protocol starts with a transaction ID, which is a unique ID for each protocol or each telegram. Then we have a protocol ID, which actually is always 0 for Modbus TCP. Then we have a length. The length specifies how many bytes are following from here. Then we have the unit ID, kind of addressing, and then the function and the data. On Modbus TCP, we no longer have master-slave, but we have client-server. So the client sends a request to the server, and the server sends a response back to the client using TCP. Here's a comparison in the ISO OSI model of the Modbus RTU and Modbus TCP. So for Modbus RTU, we are using RS485, and the specification here is on the physical layer. Then we have the Modbus serial line protocol on the data link layer, and the Modbus application protocol on the application layer. On Modbus TCP, you see here IEEE 802.3. This is the Ethernet standard here on the physical and data link layer. Then we have the TCP IP stack that we are using, and then the Modbus application protocol. So here's a Wireshark recording of a Modbus TCP communication. And as you can see here, the first three protocols or telegrams, this is the typical TCP three-way handshake. So communication establishment between the PLC and the device. And then you can see here the Modbus data exchange, query, response, and so on. You can also see here the typical default port of Modbus TCP, which is 502. So this is the typical port. Here's a Wireshark recording of a request. You can see here Modbus TCP request, and you can see this is really not encrypted. So Wireshark tells you exactly what command has been done here. In this case, it's read holding registers. And if you look down in the protocol, you see 5 registers should be read. You can also see the layer structure that I just showed you in the ISO OSI model. So this is also represented in Wireshark here. And now let's have a look at the response. So this is the query. So let's have a look at the response. And you can see inside the telegram, you see the 5 registers that have been requested, and you see also the data. No encryption, nothing. This is readable for everybody. That's the downside of Modbus. So yeah, first of all, I want to show you how to use the library, so the classical way. So on the Modbus TCP library, we have a Modbus TCP client, which can be activated. Then you have to specify IP address and port of the server. There's also an option to use Modbus UDP instead of Modbus TCP. Then we have, again, this interface to the other function blocks. And whenever the communication has been established, we have the active and the ready output set. In other cases, we have some diagnostic information here. And then again, for each function code, we have a separate function block. In this case, again, function code 3. And it is very important to activate this function block only when this function block has a successful connection to the server. not before that. I will show that in a second. Then there is this input here, empty ID. So you can add up to 10 instances of function code function blocks to one client function block. And each instance needs a unique ID here, so between 1 and 10. Then we have the update time here, the cycle time to cyclically read the data, the unit identifier, a start register, the number of registers. The data that is read from the function block is returned at the output array register value, and it shows you also how many bytes there have been received. But one thing is very important, and I will also show that in the code later. The value here, the data, is only valid with the rising edge of the new data received output. So only when there's a rising edge on the NDR output, this value is valid, which means with a rising edge, you have to copy this value to another variable. So let's have a look how that can be achieved. Go back here. So I have my Modbus TCP example here. So here's my client function block. I can activate the client, which I will do in a second. I have to specify my IP address here, the port. I don't want to use Modbus UDP mode. And when this function block is ready, and only then I will activate my function code 3 function block, which will read holding registers. So my Modbus TCP server is a sample server that I have running here on my laptop. You can see here it's listening on port 502. I have here my holding registers, and you can see here the first 5 registers. I have some values, so 1, 2, 3, 4, 5, and this is what I want to read. Let's see if that is working. So first of all, I have to activate my client. See, it's ready. And you see also here that there's some data available. And we can have a look here at the receive buffer. And what I said here with the rising edge of the NDR, the receive buffer here, the data from the function block, is copied to an array called read buffer. I'm using the select function block. So whenever there's a rising edge, the rec buffer is copied into the read buffer variable. And if the output is false, then the read buffer copies it to itself. So let's have a look here. At the read buffer, I already copied it to the watch list. It's a long one, so let's go to the top, and you can see here the register 1, 2, 3, 4, 5 are read. And if I change something, let's say the first one, I change it to 16. You see it's hexadecimal 10, so 10 hexadecimal is 16 decimal. So that works. So I have a second function code function block attached here, which can write a register. So this is function code 6, because it's the second instance. You see here the empty ID is set to 2. And I want to write something to word number 6. And I can write a value. So let's put in a value that we can verify. So hexadecimal FF means 255 in decimal. And you can see here it has been received. So there's an offset of 1. So I'm writing to word or register number 6, which is represented here at number 7. So this is just an offset here in my simulator, but you see the value has been received here. So that is also working, so both directions. So also pretty much straightforward. You just have the client function block where that is connected. You can use the function code function blocks, and do your processing. Okay. But there's another option now. So instead of using the function blocks, if you just need a client functionality of Modbus TCP and you have the latest firmware available, then you can, well, latest firmware means firmware 2024.6 or higher. And the first thing that you need to do is you have to go to the web-based management of the PLC. I will show it. Let me check here. Let me just. So you go to the web-based management of the PLC. You go to Configuration System Services, and there you will find the Modbus TCP Client functionalities. See, by default, it's deactivated, so you have to activate it. And then click on Apply and Reboot. So the, excuse me, the PLC will reboot, and then the service will be activated. So this is the first step that you need to do. When that is done, in your project, you can import a library, a system library, which is called Modbus. And then you will find in the network section, you will find a Modbus node here, and they have different clients available. A client that can connect to 8 servers, a client that can connect to 16 servers, and in the latest version, there's also a client that can connect to 32 servers. And that depends on the PLC that you are using. So the 2152 can connect up to 16 servers. That 1152 can connect up to 8 servers. And then from the component section here, you just do a click here on the client and use drag and drop it on the PLC here in the plant. And then this will add a new node here, which is called Modbus TCP, just using drag and drop. And then if you go to Modbus TCP, you find a Modbus device list. And this is where you can add different servers, up to 16 or 8, depending on what hardware you're working on. And here in the Modbus device list, you specify the IP address and the unit ID. And then you have the server here. In my case, there's only one server connected. If you double click here on the server, you can do the configuration here of the protocol, of the port, some timeouts. And then on the second tab here, they have the registers. This is where you define the function codes that you want to use. So you can see here in my case, I added function code number 3. Then you give this one a name. So this is reading hold-in register. So the direction is input. Data type is word, and then you have the address and the number here of registers. Address is the register starting address. So this is obviously the firmware version. Then you can, if you want to read, for example, the frequency, you can have a second holding register here. I call it frequency. It's another input, word, address, and so on. And this will create ports on the server here, which you can connect. This is in the data list, so you see the ports here, which we just defined, the firmware, the frequency, the vendor ID. This is where you can connect your global variables or your port variables. So this is the raw data from the Modbus. These are the variables that you can use inside your program. Of course, this is raw data. And again, you have to the data accordingly and convert it into a frequency, for example. Now, this is something that you still have to do, but you don't need any programming. It's just a configuration that you can do on the Modbus TCP client. There's also a new variable called control diag statistics. So this is a structure that you can use for statistic purposes and for debugging purposes. So let's have a look on that. So Modbus TCP client is activated. I can go to my Modbus here to the engineer. So you see here the Modbus section. I've edited it already. So you see the settings here. So you see Modbus servers, 16 servers, and 32 function codes per server. are possible. That's important. See, on the device list, you see I have only one server connected. You just disconnect so that you can better read it. So there's one server connected. This is the IP address of the server. So this is another energy meter that supports Modbus TCP. Unit ID is 1, and I can add 15 more servers if I want to. So here's my server. So now double click on the server. You see the general description of the server configuration here. You see the registers. In this case, I have 2 registers here, the firmware and the frequency, which I have configured with the address. So the address, of course, you have to look up in the manual of the device. And then in the GDS port list, this is where I connect, where I connect the ports. Well, in this case, I did it. You have the option to do that in the data list with global variables, or you can do that in the port list. I just used global variables, so I did it in the data list here. This is why I have firmware input and frequency input. Okay. Let's connect. So here's my little program for the TCP client. So the code is just the decoding. So you can see here, I receive the firmware and the frequency, and I can go to my web-based management of my EM Pro and change the frequency, let's say to 52. And then you should see that, oh, it didn't work. I'll have to log in. Okay. Yeah, and then you see the frequency has changed. And I can do that back again. So let's change it back to 50. Send. And you see the frequency is going back to 50. So this is also working. So there's no programming needed. You just need to add the servers here, the function codes, connect them with the variables, and then you have the raw values here, and you can use the functionality here inside your program. And finally, it's also possible to use Node-RED, which is a JavaScript programming environment. It's available as an app for free to download from the PLCnext store. And there you also have a node, as it is called, which is like a function block for Modbus TCP. And you can see here, you can select a function code here, specify the register address, the number of registers you want to read, a poll rate, and you specify the server, which basically is the IP address of the server. And then you also have the data available. It's just another way outside the IEC 61131 context, so I just want to mention it. It's also possible to use other programming languages, let's say, to use Modbus on the PLC. Okay, so that's it for today. I hope you learned something new, and thank you for being here.